Welcome to the viewers. We discuss today the continuations of Bessel's equations, and we now find the solution of Bessel's equations and now converting and getting the idea of Bessel's function, and after all it will come from Bessel's equations. Basically we find the solutions of this Bessel's equation and derive this Bessel's function of first kind by given definitions. At first take the solution, and the students are suggested to watch my first videos which I give to find out the root of the equation gamma. And where we start? First, we consider gamma is neither 0 nor an integer, and real gamma greater than, that is non-negative, greater than equals to 0. Then the solution of z squared w double dash plus z w dash plus z square minus gamma square w equals to 0 is, that is w is the function of z, it is here, it will be z to the power gamma sum of some constant 0 to up to infinity a k z to the power k. That is a series is form of a Taylor series, and it is a power type of series. When we are taking the solution, it is a type of power series solution, is equal to sum of k equals to 0 to up to infinity a k z to the power k plus gamma, and where this a0 term is non-negative, non-zero. And if we substitute, taking it equation number 1, if we substitute it in 1, we have, it is clear, if we taking the derivative of these terms, that is ak, and after that we are taking double derivative, and we finally write it as z square sum of k is equal to 0 to up to infinity, and if we taking double derivative like k plus gamma into k plus gamma minus 1 ak z to the power k plus gamma minus 2 plus z into sum of k is equal to 0 to up to infinity k plus gamma into ak z to the power k plus gamma minus 1 plus z square minus gamma square sum of k is equal to 0 to up to infinity ak z to the power k plus gamma is equal to 0. Now we are equating the coefficient, of z to the power k plus gamma to 0. We have here, it will be, it is clear, z to the power k plus gamma. If we 2 is adjusted here, so we are getting only these terms. So it will be k plus gamma into k plus gamma minus 1 ak. Next term will be it will be z. So here it will be k plus gamma, because z will adjusted here, into ak, plus here we should clear, if we break these terms, it will be z to the power k plus 2, so that will be ak minus 2, because k plus gamma plus 2, that's why. So it will be ak minus 2. If we adjust this term, ak minus 2, because k plus gamma plus 2, that's why. So we subtracted it, and minus k plus gamma plus 2 into this way, and next term will be minus of gamma square into simply ak, that will be 0. So we are getting in this result. Now we have to adjust few terms to calculate it and going into the simplifications. Therefore we rewrite this term once again, gamma plus k minus 1 into ak plus gamma plus k, or k plus gamma, whatever may be the commutative property, ak plus ak minus 2 minus gamma square ak is equal to 0. And if we break these terms, what we find it here, and simply we find it gamma plus k whole square ak minus gamma plus k into ak. So it will be plus gamma plus k ak plus ak minus 2 minus gamma square ak is equal to 0. And if we break this bracket, these two terms already cancelled, so it will be gamma square ak plus 2 gamma k ak plus k square ak. Already we cancel these terms, plus ak minus 2 minus gamma square ak is equal to 0, already cancelled. So finally we find these terms like this. If we taking common, that is k, so it will be twice gamma plus k ak is equal to minus of ak minus 2. So it will be ak is equal to minus ak minus 2 by k into twice gamma plus k. And it is clear all these terms are non-negative, so it will be, if k is minus 1, then a of minus 1 is 0. That is a1 is equal to 0. Since a1 is equal to minus of a minus 1 by, if we putting this 1 into twice gamma plus 1, that will be 0. A of minus 1 0, that's why. So if we substitute all, if a is equal to 2, then it will be a 0, certainly it will be 0. A is equal to 3, that will also be a equals to 2 is okay, but a equals to 3, then it will convert it to a1. So that's why all even term, odd terms are 0. If k is equal to all odd terms, then ak is equal to 0. Now we calculated even terms. If k is equal to 2, 4, 6 ... then a2 is equal to minus of a0 by 2 into 2 gamma plus 2. So that will be minus of a0 by 2 square into gamma plus 1. a4 is equal to minus of a2 by 2 into that will be clearly said, that is 2 square into 2 gamma plus 4. So that will be already replaced by these terms. So it will be minus of a0 into, here it is also 2 to the power 4, and if we considering 2 into gamma plus 1 into gamma plus 2, and that is certainly converted to minus of this 1 whole square. So it will be minus 1 whole square, a0 by 2 to the power 4 into 2 factorial gamma plus 1 into gamma plus 2. If we considering a6, that will be minus, similarly minus a0, and it is clear, that is minus 1 whole to the power 3 2 to 3, and it will be clearly, it will be 2 to the power 6 into 3 factorial into gamma plus 1 gamma plus 2 gamma plus 3, in this way. So if we considering the generalized term a twice k for k is even, minus 1 whole to the power k a0 divided by 2 to the power twice k into k factorial gamma plus 1 into gamma plus 2 into gamma plus 3 up to dot 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 up to gamma plus k, in this way. So we have to find this type of result, and now therefore the required solution is given by wj, that will be clear, we are writing this coefficient, and also initial equation taking outside a0 and z to the power gamma, and writing in this way, k is equal to 0 to up to infinity minus 1 whole to the power k a0 divided by, we write it here, 2 to the power twice k into k factorial into gamma plus 1 gamma plus 2, in this way, and up to gamma plus k. Now substituting a0 is equal to 1 by 2 to the power gamma into gamma of small gamma plus 1. If we substitute in this one, is the concept of beta gamma function, and now substituted, we are writing the solution, that is the solution becomes j gamma, that is the problem of Bessel, that is the concept of Bessel's function, j gamma denoted by 1 by gamma plus, that is gamma of gamma plus 1, and if we substituted it in the outside terms, if we substituted a0 simply by this way, a0 and it will be z to the power gamma, and that is z by 2, z to the power gamma and 2 to the power gamma, that is z by 2 whole to the power, and sum of k is equal to 0 to up to infinity minus 1 whole to the power k, z to the power twice k divided by 2 to the power twice k, k factorial, gamma plus 1, gamma plus 2 up to it will be gamma plus k, and then the result will be j gamma z is equal to sum of k is equal to 0 to up to infinity. Here it will be minus 1 whole to the power k, and if we take it z by 2 whole to the power, that is z by 2 whole to the power gamma plus twice k, gamma of gamma plus k plus 1 by gamma of gamma k plus 1. It should be noted here, gamma of gamma plus k plus 1, that will be gamma plus 1, gamma plus 2 dot 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 up to gamma plus k, and gamma of k plus 1 will be given as k factorial in this way. Now we say this is as a Bessel's equation solution is given by this. If replacing gamma by minus gamma, we obtain j of minus gamma z, that will be sum of k is equal to 0 to up to infinity minus 1 whole to the power k, z by 2 whole to the power minus gamma plus twice k divided by gamma of minus gamma plus k plus 1 into gamma of k plus 1. Therefore, the general solution, that is general solution, better to say, the solution of equation, the solution of equation, it is called general solution of equation z square w dash plus z w dash plus z square minus gamma square w is equal to 0 is, that is w of z by omega of z or omega of z equals to a1 j gamma z plus a2 j of minus gamma z, where a1 a2 are arbitrary constants. Now the Bessel equation, that is Bessel function jnz of first kind of order n, real or complex, whatever may be, is given by jnz, that will be sum of k is equal to 0 to up to infinity minus 1 whole to the power k, z by 2 whole to the power n plus twice k divided by gamma of n plus k plus 1 into gamma of k plus 1. This is the Bessel's functions. So we end our discussion today to give some of the idea of Bessel's equation, solution of the Bessel's equation, and then Bessel's functions. If you like this video, like it, share it, and once again we just mentioning here and to end this discussion. If we replace n by minus n, then j of minus nz, that will be sum of my a equals to 0 to up to infinity minus k whole to the power n z by 2 whole to the power minus n plus twice k by gamma of minus n plus k plus 1 into gamma of k plus 1. We are finding in this way, and now we are getting in this sense. But in the next video I will discuss what these things happen. Now keep watching my videos. Thank you.